Hey guys, I welcome you all to this live session by Great Learning. So today's topic is programming for data science. And before we start off with the session, I'd actually like to apologize to you guys for the delay. So we had some technical issue at our end. Now we've got it sorted. So let's go ahead and let's have a quick glance at the agenda. So now for data science, we've got two very important languages, and those two languages are Python and R. So in the previous live session, we had covered some data science concepts with Python, and in this particular session, I have been speaking. It is there. Uh, yeah. Hey guys, sorry again for that. So let's go ahead with the session. So as I was saying, we've got two very important languages when it comes to data science. We've got Python and R. So in the previous live session, we had covered Python, and in this particular session, we will go ahead with R. So we'll start off by installing R and R Studio into our systems, and then we'll look at some basics of R. After that, we'll cover all of the data structures in R, which would be list, vector, data frame, and an array. Going ahead, we'll also look at some inbuilt functions. Now, once we're done with all of these, we'll work with some flow control statements in R. So when I say flow control statements, those are basically the if-else statements. Now, if-else statements are known as the decision-making statements, and apart from the decision-making statements, we've also got the looping statements. So these looping statements are for and while. Now, once we're done with the looping statements, we'll go ahead with the user-defined functions. So we'll see how to create user-defined functions, and we'll create some user-defined functions. And finally, we'll head to the data science part, where we'll do some data manipulation operations, and we'll also do some data visualization operations. So guys, that'll be the agenda for today's session. Right. So our first task would be to install R, and to install R, we can go ahead to this particular site over here. So we'd have to go to cran.r project.org. So let me just click on this link. So as you see, we've got different distributions of R. So if you're using a Windows system, then you can download R for Windows. If you're using a Linux system, then you can download R for Linux. And if you're using a Mac system, then similarly you can download R for Mac. And since I'm using a Windows system, I'll go ahead and click on this particular link over here. And if you're installing R for the first time, you can go ahead and click on this. Now, this is the latest version of R, 3.6.3, and this is for Windows because I'm using a Windows system. So I'll just go ahead and click on this. So as you see, the download is starting. Now, since I already have R installed in my system, I'll just cancel this. Now, after installing R, we'd also need an IDE. So in the previous live session, when we were working with Python, we had seen that Python had IDEs such as PyCharm, and it also had Jupyter Notebook. Now, when it comes to R, the most popular IDE is R Studio, because R Studio makes working with R very seamless. It actually feels very magical when you're working with R Studio. And to install R Studio, you'd have to go to this particular site over here, rstudio.com. So I'll click on this particular link. Now, since you want the free version, so we've got R Studio Desktop, and this is the free version. I'll click on download. So as you see, we've got this over here, download R Studio for Windows, and this is around 149 MB. And once I click on this, the download would automatically start. And since again I've already installed R Studio in my system, I don't have to download it, so I'll just click on cancel. So we've installed R into our system, we've installed R Studio into our system. Now it's time to look at some concepts of R. Now when it comes to any programming language, variables and data types are common with respect to all of these languages. Because what are we doing with respect to programming language? We're working with data. And how do we work with data? Well, you have to store that data somewhere, and this is where variables come in. So we'll take the same example. Now let's say you have a phone with you and you want to store this phone somewhere. So consider this to be a storage space. So what you do is you take this phone and place it in this storage space over here. You can consider this to be a variable for now. Now after some time you decide that I don't really need a phone and I actually need a pen. So you throw out your phone. Well, because you're rich, you don't really need an iPhone, and you want to you feel that a pen is more useful than an iPhone. So you just take your iPhone, throw it in garbage, and you take your pen and then you store it in this particular bag over here, which is again your variable. Now after some time you think that, well, I'm not really a writer and it's better if I become a model. So you throw out the pen and you decide to buy a makeup kit, and you store that makeup kit in this particular storage space over here, which is again your variable. So the underlying concept of variable is very simple. It's a temporary storage space where you can store values, or you can basically keep changing your values in this particular variable. Now, once we know what a variable is, it is important to know that a variable also has certain data types with it. So a variable can be numeric, character, logical, or complex. So when you store numbers such as 3.14, 75, or 500, what you're doing is you're storing numerical data into these variables. And the data type of the variable would depend on the value which you are storing in these variables. Similarly, when you store characters such as Sam, Bob, or you basically when you store sentences such as I love iPhone, or iPhone 11 is very expensive, that again is character data which are storing in these variables. Then you have your logical values which are true and false, and then you finally have your complex values. So 7 plus 5i minus 3 minus 9i, all of these are complex values. So over here 7 would be the real part and 5 would be the imaginary part. So on the left side of the plus symbol you've got your real part, and whatever accompanies this I, that is known as the complex part over here. So in a complex number you would have your real part and then you have your imaginary part. So these are the types of data in R. So we've understood what are variables, we've understood what are data types. Now let's go to RStudio. So let me just go to RStudio. Right guys, so this is how RStudio looks like. Now before we start off with the coding session, let me explain each of these panes for you. So as you see, we've got 4 panes over here. So this pane or this window which you see, this is known as the script window, where you write all of your script or code or whatever you call it. So basically you can store all of your code or you can store all of your script in this particular window over here. So that helps you to have a glance at all of your code at one particular time. And if you want to execute your code, that is when this console window comes in. So this window which you see, this is known as the console window, and if you have to execute something, you can execute it over here. Then you got the history terminal over here, so you can see the history of all of the commands which you have executed, right? So this is the history of all of the commands which you have executed. And then finally you have this particular tab over here. So if you want to create some plots, you can visualize all of those plots over here, and whatever packages you have, or if you want to install new packages, you can have a glance at all of these over here. And if you want to want help with respect to something, then you can go to this particular tab, right? So these are the 4 different panes when it comes to RStudio, right? So we've got a basic gist of RStudio now. Now again, let me show you these particular tabs over here. So we've got the file tab. You can create a new file, you can open a file, you can rename it, and if you want, you can also download it, right? And then you've got the edit, so you can undo, redo. You've got all the basic options over here. Now let's say if you want to change the background of this, then you can go to tools, and then you have the global options over here. Now inside this you have the appearance option, so you can choose whatever appearance you like. If you like blue color, then you can go for this. If you like this, you can go for this, right? So you've got different themes for your RStudio as well. And let's say if you can't really see your screen properly, then you can also increase the size of your text over here. You can zoom your text. So this is something which you can also do, right? Okay, so now we will go ahead and work with variables. So as I've told you, variables are basically temporary storage spaces. Now let's go ahead and create a first variable. So over here I am creating my first variable a and I'm storing the value mobile inside it. Now let me just print out a over here again. So when I print out a, as you see, mobile is stored inside a. Now after some time I decide to store the value pen inside a. Now I've stored pen inside a and let me print out a over here. So as you see, mobile has been replaced with pen. Similarly, I will go ahead and change the value of pen to makeup. Now when I print out a, you see that pen has been replaced with makeup. So this is how you can store values in a variable. So we already know what a variable is. Now let's see how can we work with different data types or assign different data types to a variable. So over here we are working with a numerical data type. So we have a variable with the name num1 and inside that variable I am storing the value 3. Now let me print out num1 over here. So as you see 3 is stored inside num1 and if I want to check the type of it I'll just use class and inside class I'll give in the name of the variable. So as you see this is numeric. Now I will go ahead and store hello in a new variable which is character1. I'll print it out. Let me print out char1 over here. Right, so hello is stored in char1. Let me check the class of this. So I'll type class of char1 and as you see the character of this or basically the type of this is character. Now similarly I'll go ahead and store a logical value inside this. So we've got true over here. Now you need to keep in mind that all of these have to be capital. TRUE. All of these have to be capital. If you keep even one of them to be small, then it will not work. Now let me print out log1. So we've stored true in log1. Let me check the class of this. So I'll type class of log1 and as you see this is of logical type. Now similarly let me go ahead and store a complex value into this. So this time I am storing 4 plus 7i and complex 1. Let me print this out. So I've got complex 1 over here. I'll also check the type of this. So class of complex 1 and as you see this is of complex. Right, so this is how we can create variables and this is how we can assign different types of data to a particular variable. So now that this is done, we'll go ahead to the next concept which are operators in R. So we've got assignment operators, relational operators, arithmetic operators and logical operators. So when we are doing the live session with Python, we had work with all of these. Now let's see how can we do the same thing with R as well. So there's not much of a difference, it's just that the language has changed but the concept pretty much remains the same. So first we'll actually start off with the assignment operators. So in Python, the only way you could assign a value to a variable was by using an equal to operator, which you can also do in R. Now let's say if I want to assign the value 1 to b, what I'll do is I'll set b and then I'll put in equal to and then I'll put in 1 over here, and this is how I am storing the value of 1 in b. So now that this is done, there is also another way. So if I want to store a value, I can also use the less than symbol and then I can put in a hyphen. This is a different assignment operator, but it does the same purpose. So now, let's say inside B I want to store 10. Now let me print B, right? So initially the value 1 was stored. Now I am using a different assignment operator and I am storing the value 10 inside B. Now similarly, instead of using less than symbol and hyphen, I can also use hyphen and then put in the greater than symbol. Right, so over here this is actually a bit different. So first we given the value. Let's say the value is 100 and I am storing the value 100 in B. Now let me print out B. Right, so we've stored the value of 100 in B. So these are the assignment operators. Now we can work with the arithmetic operators. So I'm assigning the value 10 in num1 and I'm assigning the value 20 in num2. Right? So 10 is stored in num1 and 20 is stored in num2. Now, once this is done, let me go ahead and perform some arithmetic operations. So, my first arithmetic operation would be addition. So, over here, I am adding the first two numbers, or basically num1 and num2, and it gives me 30 because 10 plus 20 is nothing but 30. Similarly, if I want to subtract these two numbers, all I have to do is put in num1 minus num2, and I get 10 minus 20, which is minus 10. Similarly, if I want to perform a multiplication operation, I'll use in both of the operands. So over here it becomes num1 into num2. So it is basically 10 into 20 and it gives me a value of 200. So the multiplication is also done. Let me go ahead with division now. So num1 divided by num2 would be 10 divided by 20, which would give me a value of 0.5. So these are the basic arithmetic operations. Right, guys. So guys, if you have any questions till now, you can put all of your questions in the chat box. So our team will respond you as soon as possible. Right. Also, if you guys have not subscribed to our channel yet, please do subscribe, as we'll be pushing out a lot of live channels every day. Right. So if you want to learn more with respect to different domains, if you want to learn new technologies, please do subscribe to our channel so that you get notifications of all of these, and will also encourage us to create more such high quality tutorials. Right, so we were done with the basic arithmetic operations. Now we will go ahead and work with relational operators. So now let me just print out num1 and num2. So we've got 10 in num1, 20 in num2. Now I want to see the relation between these two. So I'm checking if the value in num1 is less than num2. So is 10 less than 20, we get a true value. Now similarly, let me check if num1 is greater than num2. We get a false value because 10 is not greater than 20. Now let me check if num1 is actually equal to num2. We get a false value because 10 is not equal to 20. Now I'll use the not equal to operator. So the not equal to operator is basically the exclamation mark and equal to. So num1 exclamation mark num2, and I get a true value because 10 is not equal to 20. So these are the basic relational operators. Once we're done with the relational operators, we'll head on to the logical operators. So we've got two logical operators. We've got AND operator, OR operator. So the AND operator gives you a true result only when both the operands are true. And when it comes to the OR, it gives you a true result when either of the operands is true. Right? Now let's understand that with an example. So over here I have two operands. I'm storing true in log1 and false in log2. So I've got both of these set over here. Now let me start off with the AND operator. Let me start off with log1 and log1. So that is true and true will give me a true value. Now let me see what would be the result of log1 and log2, and also log2 and log2. I get a false value because log1 and log2 would be true and false. Because one of the operand is false, I get a false value. Similarly, since over here both of the operands are false, I get a false value over here. So this is the AND operator. Now that we're done with the AND operator, let's go ahead with the OR operator. So when it comes to the OR operator, as I've told you, when either of the operands is true, we get a true value. So log1 or log1, what do you think would be the answer? It's true because both of them are true. Log1 or log2, again we get a true value because log1 is true. Now let's check the final one, which would be log2 or log2. We get a false value because both of them are false. Right. So these were the basic operators. Now let's go ahead with the data structures. So data structures basically help us to store multiple values into a single storage space. So we've got vector, list, matrix, array, factor, and data frame. Let's start off with vectors now. So when it comes to vectors, vectors are homogeneous single dimensional data structures. Now what do I mean by homogeneous data structure? Homogeneous means that you can store data of only one particular type in the data structure, right? Now, once a once you know that, it is also a single dimensional data structure. So when I say single dimensional data structure, that means that it is present in only one plane. You wouldn't have rows and columns when it comes to a vector. So again, I'm going to repeat it. A vector is a homogeneous single dimensional data structure. A homogeneous data structure means that you can store values of only one particular type. And when I say single dimensional, it is present in only one plane, and that is why you will not have rows and columns when it comes to a vector. Right. Now let's see some examples of a vector. So we can create a vector with the combine operator. So you type in C and you put in round braces, and then inside the round braces you give in the values. So I am creating my first vector over here, and I'm storing this vector in vec1. So C, and this is a numeric vector, and the values present inside these vector are 1, 2 and 3. Let me print out vec1 over here. As you see, these are the three values present in it. Let me check the class of it. I'll type class of vec1. You see that this is a numeric vector. Now let me go ahead and create a character vector over here. So this is vec2, and I'm storing three characters inside this. So the elements are A, B and C. This has got three characters. Let me print out vec2 over here. So as you see, this has got three characters. Now let me also check the class of this. So I'll type in class of vec2. As you see, this is a character. Right, so this is how we can also create a character vector. Now let me go ahead and create a logical vector. So this time I am creating a logical vector over here, and this logical vector over here comprises of three values t, f and t. Right, now let me hit enter. Let me show you vec3 over here. Right, so these are the values present inside this vector. Okay, so we've created three particular vectors, and till now we've only been storing homogeneous values into this vector, and that is because I've told you a vector is a homogeneous data structure. Now let's actually go against something what I've told you guys before. So now what I'll do is I will actually store heterogeneous values into this vector. So what I'm doing is I am creating a vector where I am storing logical values and numerical values into the same vector. So over here I have got two numerical values, 1, 2 and two logical values, true and false. Now what do you think the class of this would be? Any guesses, anyone? I've told you that this is a vector is homogeneous, but this time we have stored numerical values as well as logical values. So guys, what do you think would be the class of this? Do put down your answers in the chat box. Do let me know. So I'll give you guys a couple of seconds to think. Okay, right. So if you've put down your answers, let me show you guys the class of this. So I'll type in class of mix bag1. So as you see, this is numeric. Now why do you think this is numeric? Because the logical values have been coerced to numeric values, because the operator precedence comes over here, and since only homogeneous values can be stored in a vector, that is why all of these numerical values have been coerced into numeric. Right, so I'm going to repeat it. Since vectors can only store values of one particular type, that is why these logical values have been converted to numerical values. Now let me print out mix bag 1. Right, so as you see, we had stored 1, t, 2 and f. Now this t and f has been changed to 1 and 0. So operator precedence over here, numerical values take precedence over logical values, and t and f have been coerced to the logical values over here. Right, now let me go ahead and again do something else over here. So this time I'm again creating a mixture of elements over here. So this time I am passing character values as well as numeric values. So I'm printing this out. Guys, again, think for a while. What do you think would be the class of this? What do you think would be the type of this? Would this be numeric or would this be character? I'll show you the class first. So class of mix bag 2, and it tells you that this is character. So this means that a character value has greater precedence over a numeric value. So let me print out mix bag 2 over here. So as you see, these numeric values have been converted to character values. Right. Now I'll create another vector over here which would comprise of numeric values, character values, and also logical values. Now what do you think is the class of this? Class of mix bag 3. So this is a character because character has greater precedence over numeric and numeric has greater precedence of logical, and when it comes to all three of these, character has the maximum precedence. I'll print out mix bag 3. So 1 has been coerced into a character, T also has been coerced into a character. So this is how you can work with vectors. Now let's see how can we extract individual elements from a vector. Let me print out mix bag 2 over here. Now let's say I want to extract the first element from this vector. So how do I do that? So what do you think? How does the indexing start in R? Does it start from 0 or does it start from 1? Well, the indexing in R starts from 1. So this is the difference between R and Python. When it comes to Python, the indexing starts with 0, and when it comes to R, the indexing starts with 0. So since the indexing starts from 1, if I want to extract the first element from this, right? If I want to extract the first element from this, I'll give in the name of the vector, and inside parenthesis, I'll give in the index value, which is 1. Similarly, if I want to extract the second element, I'll just put in 2 over here, and I'm extracting the second element. If I want to extract the third element, I'll put in 3, and I can extract the third element. If I want to extract a series of elements, that is, I want the first element, second element, and the third element, this is how I can do it. So I'll put in 1, I'll put in colon, and I'll put in the right side index. So over here, you have to remember that both the initial index and the final index, both of them are inclusive. So 1, you'll also get a value, and 3, you'll also get a value, right? So this is the concept when it comes to a vector. Now let's head to the second data structure, which is a list. So what is the difference between a vector and a list? Well, the similarity is actually both of them are single dimensional data structure. But the difference is, in vector you can store only homogeneous elements, but in list you can store heterogeneous elements. Now when you store these heterogeneous elements, the individual values will maintain their individual data type. So let's see how does that actually work. And to create a list in R, you will use the list function, list, and then when you put in braces, inside that you will give in the values. And that is how you can create a list function over here. So let's go ahead and create a first list. So let me paste over here. I am creating a list where we have 3 elements. So we've got a numerical value, a character value, and a logical value, and I am storing this in L1. Let me print out L1. Now you see that the composition or how a list looks is actually different when compared to a vector. A vector was printed horizontally, and as you see, a list is printed vertically, and you have different components over here, right? So over here in the first component, we've got element 1. In the second component, we've got element 2. And in the third component, we've got the element 3. So that is how you store these values over here. Right. Now, since I've also told you that these individual values maintain their identities, let's see what is the class of each of these. Now, I want to check the class of the first element. And as you see, that is numeric because it is 1. Let me also check the class of the second element, and this is character. Let me check the class of the third element, and you see that this is logical. So even though we've put these individual values inside a list, the individual values have maintained their identity. So 1 remains as a numerical value, A remains as a character value, and 2 remains as a logical value. There is no change, or these values are basically not coerced into the higher precedence type, right? So this is a list. Now let's actually go ahead and create a list of vectors. So we can have multiple vectors inside a list. So over here I am creating a list which is comprised of three vectors. The first component will comprise of the vector 1, 2, 3. Second component will comprise of vector A, B and C. Third component will comprise of the vector true, false and true. Let me print out L2 over here. And as you see, we've got three components over here, right? So the first component is a numerical vector, second component is a character vector, and the third component is a logical vector. So inside a list, you can actually have lists, you can actually have vectors, different vectors. Now I want to extract individual elements from this entire list. So let's say if I want to extract B from this. So B is the second element in the second component of the list. So this is how I'll do it. So L2, which is the name of the list, after that I'll put in braces and then again I'll put in braces. So this is second component. I'm going inside the second component, and inside the second component I want the second element. So I have extracted B. Now similarly, if I want to extract 3 from this, which is the third element in the first component, this is how I'll be able to do it. I'll type in L2 and then I'll give in the name, the index of the component. So over here 1 is the component and 3 is the index value. So this is how we are extracting this. Right. So this is a list, guys. Now we're done with a vector, we're done with a list. So these were the single dimensional data structures. Now let's head on to multi-dimensional data structures. So our first multi-dimensional data structure would be a matrix. So a matrix is a homogeneous multi-dimensional data structure. So when I say homogeneous, you can have elements of only one particular type over here. So this is how you create a matrix. To create a matrix, you will type in matrix, you will put in round braces, right? So this would be the syntax to create a matrix, and I want to create a matrix which would comprise of the first 6 numbers. So matrix, and inside this I'll pass in this vector which would comprise of the numbers from 1 to 6, and I will store this in M1. Let me print out M1 over here. So this is our matrix over here, and as you see, this has got 2 dimensions. This has got a column and this has got 6 rows. So as of now, this is a 6 cross 1 matrix. So we've got 6 rows and 1 column. Now I want to change the dimensions, that is number of rows and number of columns present in this. So that is where we have the n col and n row parameters. So initially we had created our matrix using this syntax. So if we want to change the dimensions, then we will add in the n row and n col attributes over here. So I want the number of rows to be equal to 2 and I want the number of columns to be equal to 3. So you'd have to keep in mind that the n col into n row has to be a subset or a multiple of the number of elements present in your matrix, right? So when you multiply 2 into 3, that becomes 6 and you have 6 elements over here. But if you put in, let's say 2, and if you put in some another number such as 5 over here, you will not get a result because this is not a subset of the number of elements. So I'm putting in 3 over here. So we are creating a matrix which would comprise of 2 rows and 3 columns. Now let me put in M1 over here. So as you see, we have created a matrix with the name M1 which has 2 rows and 3 columns, right? So now one thing if you notice over here is the elements are arranged with respect to row. So you've got 1, 2, 3, 4, 5, 6. Sorry, the elements are actually arranged with respect to column over here, right? So in the first column you've got 1 and 2, in the second column you've got 3 and 4, in the third column you've got 5 and 6. But instead of this, if I want the elements to be arranged with respect to rows, so I want 1, 2, 3 in the first row and 4, 5, 6 in the second row, then we have the by row attribute and we can set that to be equal to true. So M1, till here it is same, I am setting the number of rows to be equal to 2, I am setting the number of columns to be equal to 3 and I am setting by row equal to true, right? When I do this, you see the arrangement has changed. Initially the elements were arranged with respect to column, now the elements are arranged with respect to rows. So this is how you can change it, right guys? So guys, again a very simple reminder to you guys, if you haven't yet subscribed to our channel, please do subscribe because it would encourage us to conduct these live sessions during this period of lockdown. So please do share these live sessions with your peers and please do share our videos with your peers as well. It will help us a lot. Right, now let's go ahead with the session. So we are done with metrics. Now let me go ahead with the next data structure, which is an array. So an array again is a homogeneous multi-dimensional data structure. So the difference between a array and a matrix is two-dimensional, but an array is multi-dimensional, right? So when I say multi-dimensional, you can have more than two dimensions over here, right? So this is how you can create an array over here. So to create an array, you will use array and then you'll use parenthesis over here. So that's how you do it. Now what we'll do is we will actually have two vectors ready over here. So I have vec1 and vec2 to be ready. So in vector 1 I am storing 1, 2, 3, 4, 5 and 6, and in vector 2 I've stored the elements 7 to 12. So let me print out vec1 to show you guys what is stored over here. Let me also print out vec2 to show you guys what is stored over here. Alright. So we've got vec1 and vec2 ready. Now I am creating an array which would comprise of elements from vec1 and vec2. Right. So this is a vector of vectors. I've used C. And I have passed vec1 and vec2 inside this, right? So guys, if you have any confusion over here, put it down in the chats and I'll take it up, right? So we have created an array. After that, I'll use the dim attribute and then I'll set the dimensions. Now inside this dim, as you see, there are three parameters. So this 2 and 3 are the number of rows and columns and 2 is the number of dimensions. So I am creating two matrices of size 2 cross 3. Now since we've got 12 elements in total, now I am using those 12 elements this way. So 6 elements would come in one matrix, the rest of the 6 elements would come into the second matrix, right? So 2 into 3 into 2. That is the composition of this particular array over here. Let me copy this and let me paste it over here. Let me print out A1 and show you how it looks. So this is A1 and as you see we've got the first 6 elements in matrix 1, the last 6 elements in matrix 2, right? So we have created an array which comprises of two matrices of dimension 2 cross 3, right? Now this is fine. Let's see how to extract individual elements from this. So let's say if I want to extract this particular element from this. So for this the question to ask is which matrix or which dimension is this present in. So this is present in the first dimension and what is the cell number? The cell number is 1, 2. So to extract that, first given the name of the array which would be A1, put in parenthesis, given the row number which would be 1, given the column number which would be 2. After that, given the dimension number which would be 1. So from the first dimension, I am extracting that cell value which is present in 1, 2. And I have extracted 3 over here. So this is how you can extract a particular element from an array. Alright. So this was an array. Now let's see how can what is a factor. So this is our next data structure over here. So a factor is generally used to create categorical values from character values. So you would need factors a lot when you're working with machine learning models, because when you're working with real life models, there'd be a lot of categorical values, such as if you're working with different types of colors, then each color would become one particular category: blue, green, orange, yellow. So all of these would become one particular category, right? Again, let's say if you want to predict if someone has cancer or not, then having cancer would become one category, not having cancer would become another category over here. So whenever you're working with categories, that is when factor becomes very important. Now I'll start off with creating a character first. I'm creating a character array and I am storing it in color 1. Let me print out color 1 over here. So as you see, blue, green and yellow are stored in color 1. Now this is done. So let me check the class of this. Class of color 1, and as you see, this is a character. Now I will convert this into a character. So if I have to convert a character into a factor, I would have to use the as.factor method. So I am typing as.factor, and inside this I am passing in this color1 attribute and I am storing it back to color1. Now let me print out color1 over here. So I'll type in color1, and as you see, initially this was a character, but we've converted this into 3 different categories, and there are 3 levels, and those levels are organized alphabetically. Blue becomes the first level, green becomes the second level, and yellow becomes the third level. So this is what is known as a factor in R. So guys, again, if you have any doubts, please do put it down in the chat. Right. And now we will head on to the final data structure, which is a data frame. So a data frame is a mixture of everything. So in data frame, it is a heterogeneous multi-dimensional data structure. So when I say heterogeneous, you have elements of different types, and since it's multi-dimensional, you would have rows and columns in it. And to create a data frame, you would use data.frame method over here. So over here, I am creating a data frame. So in this data frame, what I'm doing is I am creating 2 columns. So the first column, I am naming it as fruit name, and this would comprise of 3 values: apple, banana and guava. And then after that, I'm creating a second column which would comprise of the values 10, 20 and 30, and I'm storing it in this object fruits. So I'm repeating it. I'm creating a data frame which comprises of 2 columns, fruit name and fruit cost, and these are the values which are present in the respective columns. Now if I have to view a particular data frame or have a glance at a particular data frame, I'll just use the view method. View, and then inside this I will pass in fruits. So view of fruits, and as you see, this is our data frame over here. So I've got apple, banana and guava inside fruit name, and I've got 10, 20 and 30 in the column fruit cost. So this is how we can create a data frame. Now if you want to extract individual columns from this, so let's say if I want to extract only the fruit name column from the fruits data frame. So first you put in the name of the data frame, which is fruits. After that you use the dollar symbol. After that you use the name of the column, which is fruit name. And as you see, you have extracted the fruit name column from the fruits data frame. Similarly, if you have to extract the fruit cost column, this is how you will do it. First, you will give in the name of the data frame, which is fruits. After that, you will put in the dollar symbol, and then you will give in the name of the column, which is fruit cost. Right? So you have 10, 20, 30. So this is how you can extract the columns and then also the numerical values from this. Right. So we've completed all of the data structures over here. Right. Now, guys, before we head off to the next part of today's session, I'd like to inform you guys that Great Learning has come up with a completely new platform called as Great Learning Academy. Right, so you can actually check out Great Learning Academy over here. This is the site over here. The link would be available in the description box. So all of the courses are available for free. If you want to learn data science, machine learning, AI, big data, so you can check out all of these courses over here. So you'll also get certificates when you complete these courses. So it's the best time to upskill during lockdown, isn't it? Right? And also, it's not just the certificates. You would have multiple coding assignments. You'll have quizzes, and you'll also have projects with all of these. Right? So please do check out this link. Right. Now, so let's head on to the next part of this. So we'll head on and work with some inbuilt functions now. Let me close all of this over here. So we have a inbuilt data set in R known as the iris data frame. Now the iris data frame over here comprises of these 5 columns and it has 150 records. So it has sepal length, sepal width, petal width and species. So these are the different features of the iris flower or the species of the iris flower. And you have 3 different species of the iris flower. You got setosa, you have versicolor and you have virginica. And you have all of these different values over here. Right. Now, as I've already told you, if you want to have a glance at a particular data frame, all you have to do is use the view method. So you'll type in view and inside this you will give in the name of the data frame. So over here I want to have a glance at the iris data frame. So I will type in iris, and as you see this is our iris data frame over here. Right. So now if I want to have a glance at the structure of the data frame, then I have the STR function. So let me just type out STR, and inside this I will give in the name of the data frame, which is iris, and let's see what do we get. So when I look at the structure of this data frame, this tells me that there are 150 observations of 5 variables. That means I have 5 columns in total and I have 150 records. And over here this tells me the data type, individual data type of each of these columns. So sepal length, sepal width, petal length and petal width, all of these are of numeric type, and species is of factor type, which has 3 levels or 3 categories, which are setosa, versicolor and virginica. And you also have a few values with respect to all of these columns over here. So if you want to have a look at the structure, you can use this structure function. Right. Now, let's say if you're working with a huge data set which has around 10 million rows. Right. Now, if you want to load up that huge data set, you can't really load up. That will take a lot of time, wouldn't it? So instead of that, if you want to have a glance at only the first few records of the data frame, then you can use the head method. So you'll type in head and then you'll pass in the name of the data frame, which is iris. Right. So this will give you the first 6 records of the data frame. So as you see, this has given us the first 6 records of the iris data frame. Now, instead of the first 6 records, let's say if you want to have a glance at the first 10 records, then you put in a comma over here and then you give in the value 10. So this will give you the first 10 records of this iris data frame. Similarly, if you want to have a glance at the last few records of a data frame, then you have the tail method. So you will type in tail and inside this you will pass in the iris data frame. So tail of iris, and this has given you the last 6 records, right? And also similarly, if you want to have a glance at the last 10 records, so you'll type in iris comma 10. Right, so this has given you the last 10 records. Now there is also another function which is known as the table method. If you want to have a glance at the frequency of categorical values, then you can use the table method. So let me just type in table over here, and I want to have a glance at the frequency of the species column. So I'll type in iris, and since I want to find the frequency of the species column, I'll use the dollar symbol and then I'll select the species method over here. So this tells me that there are 50 rows of the setosa column, 50 rows of the versicolor column, and 50 rows of the virginica column. So this is how the table method works. Now let's go ahead and work with some inbuilt functions. So we've got min, max, and mean. Now if I want to find out the minimum value, maximum value, mean value, and the range of sepal length, then I can go ahead and use all of these functions over here. So min, inside this I am passing in sepal length. This would give me the minimum value of sepal length column. Similarly, inside max I am passing in sepal length. That will give me the maximum value. Inside mean I am passing in iris dollar sepal length. That will give me the mean, and the range function will give me the method. So let me hit enter over here. So as you see, the minimum value of this sepal length column is 4.3. The maximum value of this sepal length column is 7.9. The mean value of this sepal length column is 5.84. And the range of the sepal length column is between 4.3 and 7.9. So the range is nothing but the minimum value and the maximum value, as you can see, right? So 4.3 is what you have over here and 7.9 is what you have over here. And this will give you the range. So we're done with inbuilt functions. Now we'll head on to flow control statements. So in flow control statements, we've got decision making statements and we've got looping statements. So we'll start off with decision making statements first. So decision making statements help us to make a decision as it is stated in the name. And we've got if else, right? So now with the help of this decision making statement if, what I want to do is I want to check if the value which is present in the first cell of the sepal length column. So this what you see over here, if this particular value 5.1 is actually greater than 4, then I want to print sepal length is greater than 4. So this is actually 5.1, which is true. So that is why we'll be able to print this. Let me go ahead and use the if function over here. So this is how the if syntax looks like. So I'll put in if, and inside this I'll give in the condition. So the condition is iris dollar sepal length 1 is greater than 4. This means that the first cell value of the sepal length column has to be greater than 4. And if this actually evaluates to true, then if this evaluates to true, then we'll go ahead and print sepal length is greater than 4, right? So that is what will happen. So, and as this has been evaluated to true, we see that this has been printed over here, right? So now what we'll do is we'll do something different over here. Now instead of checking if the value is greater than 4, I will actually check if the value is less than 4, right? So over here I am checking if iris dollar sepal length is less than 4. So if it is less than 4, then I want to print sepal length or whatever is printed over here. Now let me show you guys what is happening. We don't get any result over here. That is because this condition has been evaluated to false. And since this condition has been evaluated to false, we are not able to print anything over here. Right. And in this case, we will go ahead and use the else statement. So in the if condition, we are checking if the value is less than 4, print sepal length is less than 4. If this is evaluated to true, then I am going to use the else clause, and I am going ahead and I'm going ahead and I'll print sepal length is greater than 4. Now what we see is the result is sepal length is greater than 4, and we get this result because this condition has been evaluated to false, and that is why uh, we go ahead and print out the else statement, which is sepal length is greater than 4. Right. So now before we actually go ahead further, let me take up some of your questions over here. Right. So Ravi Kumar asks, what is the scope of data science? Ravi, so scope of data science is actually extremely huge. So whichever domain you take, all of the domains are using data science. So let's just take the finance domain. If you use finance domain, then finance domain uses it for credit card fraud detection, financial fraud detection, and so on. If it's the telecom sector uses data science for customer churn analysis, for market segmentation, and so on. And also, if it so we've got finance, we've got telecom, and also when it comes to medical. So let's say especially in this time of lockdown, most of the data scientists and artificial intelligence specialists are working with microbiologists to go through the data and find out if there's a way to prevent the spread of COVID-19. So there is absolutely no limit to the scope of data science, Ravi. It is used across multiple domains. Right. Um, So Bejoy asks, how do we convert a character value to a numeric value? Now let's see if that is actually possible, Bejoy. So what we'll do is we will have a vector. We'll actually have a character with the name char1 and store a inside this, and let me convert it to be numeric as dot numeric of char1, and let's see what happens. We get NA value because it is not possible to convert a character value into numeric. Now let's actually convert this into categorical and let's see what happens. So char1, we have this. So I'll put in as dot factor of char1 and I will store it back to char1. Right, now I've converted this into a categorical value. Now let me try to convert this into a numeric value as dot numeric of char1 1, right? So if you have to convert a character value into a numeric value, you would have to first convert it into a factor and then convert it into a numeric value. That is your only option over here. You can't directly convert a character value into a numeric value. So first you convert it into a factor and then you convert it into a numeric value. Right. So we were discussing the decision making statements. Now that we're done with the decision making statements, let's go ahead with the looping statements. Now let's see how to work with the for loop and the while loop. So what is a loop? So now before we go ahead and work with for loop and while loop, let's understand what is a loop. So let's say whenever you want to repeat a particular task, that is when you'll be able to use a loop. A loop is basically used to repeat something. So over here what I'm doing is I want to add the number 5 to each of the elements present in this vector. So I have a vector over here which comprises of the elements from 1 to 9, right? So in vec1 I've got 1 to 9. Let me print out vec1 over here. These are all of the values. Now I will go ahead and use the for loop. So for I in vec1, this is the condition over here. I starts from 1 and goes till the last element present in this vector. So initially i's value was 1, then i's value was 2, I becomes 3, 4, 5, 6, 7 and it will go on till 9. Now for each of those values what I'm doing is I am adding 5 to it and I'm printing it out, right? So when I is 1, I'm adding 5 to it and I'll print it out. Then it will be incremented, I becomes 2, I'll add 5 to it, it becomes 7 and I'll print it out. So this is our result over here. Initially we had a vector which comprised of values from 1 to 9. Now using the for loop what we have done is we have added 5 more to each of the initial values. Right. So this is the for loop. Now let's go ahead and do a similar thing with the while loop. So the only difference between a for loop and a while loop is, so when it comes to a for loop, it mostly sort of works on a sequence, and a while loop it can work on anything and you don't have automatic increments. You'd have to increment it by yourself. So over here initially I'm setting the value of I to be equal to 1 and this goes on till this condition. So I goes on till I becomes equal to 10. So while this condition is not false, while I is less than 10, this goes on and will print this and I value will be incremented. So initially I value is 1, this condition is true, so we'll go inside, we'll print 1 plus 5 which becomes 6 and then we'll increment I value which becomes 2. Now 2 is less than 10, will come inside the loop and then we'll print 7. Then again i's value is incremented with 1, then it becomes 3. Right? So that is how it goes on until i's value becomes equal to 10. So let me copy all of this over here. Let me print out. So as you see, initially we had the values from 1 to 10. We have added 5 more to it. So 1 to 10, all of those values have become 6 to 15. So this is how we can work with the while loop. Right. Right, guys. Now we'll go ahead and look at the final part of today's session where we'll cover user-defined function. Now the data manipulation and data visualization, since we're done for today, we'll cover it in our next session. So in our next session, we'll see how to do data manipulation with the dplyr package and data visualization with the ggplot2 package. Alright, so before that, let me go ahead and show you how to create a user-defined function. So to create a user-defined function, you just have to type in function, and inside this you give in a parameter. You can give any variable over here, so you can name the variable anything, that would totally depend on you. And you have your body over here. Inside the body you will given whatever has to be done. So I am creating a function with the name add 5, and what this does is this basically prints out a result by adding a 5 to the parameter print x plus 5. Let me show you an example. Let me invoke the function add 5. Let me pass in 10. So when I pass in 10, it becomes 15. When I pass in 100, it becomes 105. When I pass in, let's say, 50, it becomes 55. So guys, this is how you can create a new function and then invoke a new function in R. So this would be it for today's session, guys. Now, before we end the session, I'd like to again request you guys, if you haven't yet subscribed to our channel, please do subscribe to our channel, as we'll be coming up with regular live sessions every single day on data science, machine learning, AI, cloud computing, ethical hacking, and a lot of domains. We're also covering a lot of tracks, so not just data science and AI, we'll be covering a lot of programming languages as well. So in yesterday's session, we had Vishwamohan take a class on data structures and algorithms. So if you had missed out on that class, you can go through our channel and learn about time complexity and what exactly is time complexity, right? So please do subscribe to our channel, and you'll be getting notifications of our regular videos. And also, as I've told you, we've launched a completely free course called Great Learning Academy. The link would be there in the description. Please do check it out. So we've got all of these sessions over here. So as you see, these are the new sessions scheduled. Tomorrow we've got AI for Leaders by Dr. Abhinanda Sarkar from 4 p.m. to 5 p.m. So all of you fans of Dr. Sarkar, you can attend this session tomorrow, right? And you've got all of these different courses with respect to these domains, and you learn a certificate. All right, guys. So this will be it from my side. Thank you, and stay safe.